Okay, so sum and product of roots, we've got alpha, beta are the roots of this quadratic. Without finding alpha and beta, find the value of alpha squared plus beta squared. So it means don't don't factor, don't use the quadratic formula. So if we want to know, all right, so we have that alpha plus beta squared is going to be alpha squared plus 2 alpha beta plus beta squared. And I just think of that immediately when I see alpha squared plus beta squared. So if we have the sum of the roots, that's negative b over a, which is going to be 2 over 1. So this is alpha plus beta. And the product is going to be negative 1 squared because of that. And it's c over a. So this is just going to be 5. And that's alpha times beta. So if we want alpha squared plus beta squared, we're going to have to do the sum squared, but we have to minus 2 alpha beta because we want this plus this, but we don't want this. Okay? So let me just write that mathematically. So we would want alpha plus beta squared minus 2 alpha beta, and that's going to equal alpha squared plus beta squared. And that's what we want. Okay? So here we're going to have 2 squared, because that's alpha plus beta, minus twice the product. All right? So that's going to be 4 minus 10, which is negative 6. So B kind of has nothing to do really with A. So if we want to find a quadratic with integer coefficients that has the roots alpha over beta and beta over alpha, we can find the sum of those, and that's going to be alpha over beta plus beta over alpha, which is going to be alpha squared plus beta squared over alpha beta when we make the same denominator, okay? Now, okay, so I guess it does have stuff to do with the first one. The product of those is going to be alpha over beta times beta over alpha, which is going to be 1. All right, so we have that this sum is equal to negative b over a, and this product is equal, and it's quadratic, so it's going to be negative 1 squared, which is positive 1, and c over a. So that means that we have, so here we'll have alpha squared plus beta squared is going to be negative 6 from that over the product, which is 5, and that equals negative b over a. So we can see that a is 5, b is 6, and this one, a is equal to c, so c has to be 5. So we're going to have 5x squared plus 6x plus 5 equals y. Okay, so this one's similar. The roots, okay, so we're going to have the sum is equal to negative b over a, which is 1, and the product is equal to, it's squared, so it's going to be a positive, and it's c over a. All right, so we're going to have alpha plus beta squared is alpha squared plus 2 alpha beta plus beta squared. So if we want alpha squared plus beta squared, we have alpha plus beta squared minus 2 alpha beta, and that's equal to alpha squared plus beta squared, which is 13. Okay. So the sum of the roots is k squared, because alpha plus beta. And the product is k plus 1. All right, so now we've got a quadratic minus 2k minus 2 minus 13 is minus 15 equals 0. And this is going to be k minus 5, k plus 3. And we have k is 5 or k is negative 3. All right, so we know it's divisible by that. So we have that factors to x minus 2, x minus 1. So we know f at 2 is 0, f at 1 is 0 because of that. The sum of the roots is 7. So 7, the sum is negative b, which this is b, over a, which is 1. So I'm not going to put it. So a is negative 7. Negative 7. And then the product, which is 0, equals, it's to the fourth, so it's going to be a positive. Negative 1 to the fourth is positive. The constant term over the leading coefficient 1, so d is 0. So now we can rewrite this. So we're going to have x to the fourth minus 7x cubed plus bx squared plus cx plus 0. And now we can use the fact that 0 is going to equal 2 to the fourth, which is 16, minus 7 times 2 cubed, so that's minus 56, plus 4b, plus 2c. So if we simplify this, this is negative 40 equals 4b plus 2c, and divide by 2. So that's one equation, and then we'll have 0 equals, when we substitute in 1, so I have 1 minus 7 plus b plus c, so negative 6 equals b plus c, and we can subtract, so we're going to have 14 equals b, and the c's are eliminated, and then this can go into this one, so we'll have 6 equals 14 plus c, and that will be negative 8. So c is negative 8. So those are our A, B, C, D. So now we want to factorize this thing. So if we write it out, f at x is x to the fourth minus 7x cubed plus 14x squared minus 8x, and then plus 0. So straight away we can factor out an x. And now we know that 2 and 1 go into this, so we can do 2. I'm just going to synthetic divide because it's easy. And we're just doing this one, so we're going to have 1, negative 7, 14, negative 8. Bring down the 1, multiply 2 by 1, 2, add, multiply 2 by negative 5, add, multiply 2 by 4, and add. So now this equals to x minus 2, and where this was x cubed, this drops down to x squared. So that's going to be x squared minus 5x plus 4. And we can factor that. And we also know that 1, so x minus 1 because of up here. And this is going to be x minus 4. Yes. So if we were to graph this, we're going to have 0, 2, 1, and 4 as our x-intercepts. And it's going to start like this and end like this because it's to the 4th, and that's how x squared is. And then what goes on in here is something like this, but we would need calculus to find these maxes and mins. Record time, 33, 11 minutes in. Polynomial that is divisible by that, so we know f at 1 is 0, and the quotient of the division is the polynomial qx. So find the sum and product of the roots. So we're going to have the sum is equal to 2, negative b, negative second term over a, which is 1. So the sum is 2. And the product is going to be even. Negative 1 to the 4th is even c over, sorry, not c, but like the constant over the leading. Okay, so that's A. For B, state the degree of Q. So since we're dividing x to the 4th by x to the 1, it's going to be degree 3. It's going to go down 1 because we're doing x to the 4th over x. C, find the sum of A and B. So we're talking about this A and B. We don't have much to go on. The sum of the roots is dealing with the first two coefficients, so not A and B. The product's dealing with the constant coefficient, the first one, so not A and B. The only other thing we've got to go on is f at 1 is 0. So we can have 0 equals 1 to the 4th minus 2 plus A plus B, there it is, plus 3. And that's negative 1, 2, so negative 2 is A plus B. All right, D, we have find the sum and product of the roots of Q at X. So I'm just gonna kind of wing it and do synthetic division. 1, 1, negative 1, negative 1, A minus 1, A minus 1. So this is going to be, because you're adding B plus A minus 1, and then this is going to be B plus A minus 1, and this is going to be 3 plus B plus A minus 1. So we are going to have, this was x to the 4th. This is going to be x cubed, so we're going to have x cubed minus x squared plus a minus 1x plus b plus a minus 1 constant term. And this, because they said it's divisible by that, this needs to equal 0. So b plus a is, equal to negative 2, like we got in C. So this here, b plus a, is also going to be equal to negative 2 minus 1, which is negative 3. So we're going to have x cubed minus x squared plus a minus 1x, then minus 3. This is what q at x is going to be equal to. So now we have the sum is going to equal negative the second coefficient, so a negative 1 over 1. So 1, that's the sum. The product is going to be negative 1 cubed, so negative, constant term, negative 3 over leading coefficient. So we're going to have positive 3 here. So you didn't even really need this thing. All right, this one, the sum and product of roots. Okay, so we have the sum is negative b over a is going to be 8, and the product is going to be positive, and it's going to be 16 over a equals 8. So this one, a is 2, which makes b negative 16. So that is a. Now for b, the polynomial f of x is divisible by x minus 1, and it's that. And when f of x is divided by x plus 1, the remainder is 120. Find the values of c and d. Okay, so we have f at 1 is 0. So we're going to have a plus b plus c plus d plus 16. So we're going to have c plus d is negative 2. And we are going to have, when it's divided by negative 1, we're going to have 120. So that's going to be a minus b, so plus 16, plus c minus d plus 16. So 32, 34, and 120 minus 34 is 86. And that's c minus d. So if we add or subtract these, I'll just subtract these two, So we're going to have negative 88 equals, c's canceled, d minus a negative e, so 2d. So d is negative 44. And if we pop that into, I'll just do in the top one, we're going to have negative 2 equals c minus 44. So c is 42. So we will have f of x equals 2x to the 4th plus minus 16x cubed plus 42x squared minus 44x plus 16. And we need to divide this by x minus 1 because q at x is here. So I'm going to do synthetic division. 1 to negative 16, 42, negative 44, 16, 2, negative 14, negative 14, 28, and 28, and 16, negative 16, and negative 16, 0. Okay, so that means that this is equal to x minus 1. And I'm going to factor out a 2 of this. This was x to the 4th. This is x cubed. So we're going to have x cubed minus 7x squared. I'm dividing all of these by 2 because I factored it out. Plus 14x minus 8. And this is q. And now we want the sum and product of those. So the sum is going to be negative 7 over 1. Second over first. And product, it's going to be negative because of the cubic. And we're going to have negative 8. So this is actually positive 8 over 1.